All right, horizontal asymptotes. In a way, this is also going to infinity, but it's a different direction. So before our last video, we talked about vertical asymptotes and a function going up and up and up to positive infinity or down and down, down to negative infinity. But now we're talking about what happens as x gets infinitely large. So what happens is if I go this direction forever, or what happens if I go this direction forever? That's x going towards positive infinity or x going towards negative infinity. So those are limits at infinity, and those are things that we can actually evaluate as well in calculus. So it's pretty cool. Let's go to the next page. So basically we have three different scenarios or three cases that'll help us understand these infinite limits, as you will. So the first one is if the degrees are the same. What I mean by degrees is, the highest variable in each expression. So for example here, x is to the first power, and down here x is also to the first power. So these two both have the highest degree, and they're the same. So when they're the same, you just simply disregard anything else. So these constants don't matter once we get to infinity, and you disregard the x's themselves, and all that's left is 2 over 1. Therefore, this limit as x versus infinity is actually 2. Pretty simple rule. The next situation is when both of these are when the degrees are not the same. So what happens if the degree on top is actually bigger? Well, if the degree on top is bigger, then that means it's going to go up and up to positive infinity. So as we go infinitely to the right, it's going to go infinitely up. The last situation is, what if the degree on the top is smaller now? So if it's smaller, then it's going to always equate to 0. So it's going to, as we go over to infinity, it's going to get closer and closer to 0. Those are really the only three situations that we see here when we're talking about infinite limits. So let's give it some practice. All right, here's the first one. It says use the graph to see what is occurring as x approaches infinity, or at x approaches infinity. Well, we can kind of see, we can verify that it looks like it's going closer and closer to 0. But let's just look at our expression here. Well, there is no x value, so if I wanted to, I could write this as x to the 0, because x to the 0 is just 1. And here I have x to the 1. Well, that means that the degree on top is smaller than on bottom. So this is one of those scenarios where it's approaching 0. All there is to it. Let's go to the next one. Okay, got a few different examples here. Let's take a look at this one first. Well, right away I see that the highest degree of each of these is 2. And so that means I can disregard the 5 and the 1, and I can actually disregard the x squared. And all that matters here is the 2/3. So this actually is going to approach 2/3. That means as this function goes infinitely to the right, it's going to approach this horizontal asymptote of 2/3. It's going to get closer and closer and closer to this asymptote. That's all it really means. So as we get farther and farther, it's going to actually, at infinity, when x is actually infinity, which we can never view, but when it is, it would equal 2/3. Okay, pretty cool. Let's take a look at this one. Very similar problem, or so it seems, except for that these degrees are not the same. The one on top is bigger, therefore, when the numerator, the degree of the numerator is larger, it means it's approaching infinity. So that's all there is to it. Also, it should be noted here, it's approaching positive infinity because all these values are positive. So this is going up and up and up. If there was a negative in here, it could be approaching negative infinity as well. So, but these numbers are all positive, therefore it's going up and up and up. If one of these numbers were negative, then we could say it's going down and down and down. Okay. Let's go to example number 3. Now I'd encourage you to just try these on your own first, see if you can figure them out. Maybe pause the video and check back in a second. Okay, so hopefully you've tried them on your own, but let's just take a look at it. First thing I notice is that this is a degree of 1, and down here there's a degree of 2. So that means the numerator, the degree is smaller in the numerator than in the denominator. So when x approaches infinity, this is just going to equal 0. Pretty easy. Okay, over here, hopefully you didn't get tricked. This is not a variable. Pi is a constant. So it doesn't matter what power it is. This is just some big constant. Maybe a huge number, but it's irrelevant with respect to infinity. It's insignificant when you think about infinity. Even if this was like in the billions, it would be infinitesimal compared to infinity. So, what are we looking at here? Well, we're looking at the fact that the degree is higher on top. And again, when the degree is higher on top, that means we're approaching infinity. And since all these values are positive, we're approaching positive infinity. That's really all there is to it. Hope I'll see you guys on the next video.